All right, today's gonna be a really fun day. Today we're gonna be working with factor strings and prime factorization. The other day, I believe it was on lesson 1.6, we worked with some prime factorization where we had those trees and we're dealing with prime numbers and composite numbers. We're gonna be doing some more of that today. Before we begin, I want you to take a look at all of these facts up here. And then in a second here, you're going to be pressing pause, and then I'll put the answers up there. So go ahead and press pause right now while I put the answers up. All right, hopefully you can take a look at these. Hopefully you got most of these correct. Ones that kids always kind of get confused with, this 8 times 6, they forget that that's 48. Another common one is anything with these 9s. Kids make mistakes on. I'm going to teach you a quick little trick. I know I've taught you this before. I'm just going to kind of re-emphasize these things. Take a look whenever you're multiplying by 9, okay? Take a look at this 6 right here. What's one number less than 6? That's 5. And then 4 plus 5 equals 9. All of the answers when you're multiplying by 9 equal 9. So take a look at this number 8. 7 is 1 less than 8. 7 plus 2 equals 9. 9 times 7, so what's 1 less than 7? We have the number 6, right? 6 plus 3. Let's take a look at this. 4 times 9, right? What's 1 less than 4? 3. 3 plus what equals 9? 6. Hopefully that little trick helped you out. Let's kind of move on here. Prime factorization of 24. Today you're going to be working with factor strings and factor pairs, or prime factorization like I just mentioned. So kind of follow along here. So I'm breaking this apart here. First of all, I'm going to break apart 24. So I'm going to go 6 times 4, okay? 6 times 4 equals 24. Do I have a prime number here yet? I don't, okay? So my bad. I'm not going to circle that. If I'm paying attention, okay? So I can break these apart then because they're both composite. 2 and 3, and then we have 2 and 2. So if you take this in mind here, now these are all prime numbers, so I'm going to go ahead and circle this. This is the first thing you're going to have to do when you're dealing with numbers today. You're going to find the prime factorization. This is going to be the longest factor string. So here's what a factor string looks like. 2 times 2 times 2 times 3. That's your factor string. How many numbers are in your factor string? 4 numbers are in your factor string. Now they're going to ask you, what are some other numbers that you can multiply to get to 24? Well, one we have right here, we have 6 times 4, and that's 2 of these numbers. Now this is in prime factorization. Now we're writing down factor strings. We know we have 8 times 3, right? Okay. What are some other routes? We're taking a look at these numbers here. 8 times 3, we have 6 times 4. What about 6 times 2 times 2? So I'm breaking apart this one, right? We have a 3 here. What if we did 6 times 2, so we got 12 times 2? That factor string's too long. So 24 has got a lot of different factor strings. Then they're going to ask you how long they are, okay? And I might be missing one here. Just take a look here. Am I missing any? So we have 6 times 4. We have 2 times 2 times 2 times 3. I believe we might have all of them now. Let's take a look at this next page here. Okay. Trying to help you out. So we have 6 times 4. 2 times 3 times 4. That's one of the ones I was missing on that other page. Okay. There's a lot of them for 24. Let's keep on rolling here. Take a look at this page here. So we're going to do it here. We're going to make some factor strings for 30. So this is what your math journal is going to look like today. So let's take the number 30. On a sheet, we'll go with a sheet of new scratch paper here. Let's break it apart. I want you to follow along with me on your scratch paper so you have an idea what I'm doing here. Let's break this apart right away. We're going to go 3 times 10, right? 3 is a prime number, so I'm going to circle it. I'm going to go ahead and break 10 apart to be 5 times 2. These are all prime as well. So actually, my first factor string is going to be 5. I'll start off small, then get bigger. That's what I want you to do. 2 times 3 times 5. How long is this? There's 3 numbers. That's where you get the length. Please watch the video over and over again to understand what my directions are on this. Kids always kind of get confused here. Now I'm going to take a look at these numbers here. How can I break them apart? I can go 2 times 3, which equals 6 times 5. You see how I did that? I just took these two numbers. That's a length of 2. What if I did 2 times 5, which would give me 10, times 3 would give me a length of 2. And then if I did 3 times 5 is 15, times 2, and I want the times 2. All right, hopefully that helps you out a little bit. Let's take a look at 50. Let's break it apart. I've got to make the longest factor string possible. 5 and 10. 5 is prime because the reason why 5 is prime is the only way I can break it apart is 1 and 5, and then I have 5 again. So then that's kind of a waste of time. So let's go ahead and circle the 5 so we know 5 is prime. Circle that, and we'll change 10 to 2 and 5. So my longest factor string is 2 times 5 times 5. So jump back to this page so you have an idea what's happening here. Two times 5 times 5. This is 3 numbers long. I'm going to change colors here. What's 2 times 5 is 10 times 5. That's the factor string of 2. Let's take a look at another one here. What if I go in 5 times 5, which is 25, times 2? Are there any other ones here, kids? We have 10 times 5. 5 times 5 is 25 times 2. I believe those are all of them, aren't they? I believe so. And if I miss one, go ahead and correct me. But I believe those are all of them right there. Those are the ways to get 25. Should we do one more together? I'm going to do one more to help you out. Let's do 54. So I'm going to start with the prime factorization. So when I'm walking around the room here, I should be seeing a lot of scratch paper being used for all these prime factorizations. So we have 54. We're going to break 54 apart. What two numbers times each other equal 54? Let's go with, well, I know it's factorized. We have 6 times 9. No prime numbers yet because I have 2 times 3 and 3 times 3. These are all prime numbers. So my factor string is 2 times 3 times 3 times 3. There's my factor string. So I'm going to jump back to this page because it's going to look most like your assignment. So 2 times 3 times 3 times 3. It's 4 numbers long. Change colors here so you can follow along. I can go 2 times 3 is 6 times 3 times 3. That's one way of doing this. What if I did 3 times 3? 3 times 3 equals 9, not 3. If I did 3 times 3, so if I took these two numbers out, I have 9 times 3 times 2. And then the last one, I need to put the basic one, 9 times 6. Count the factor, or the length. 2. So I hope this makes sense. You want to start with the big one. So it ends up kind of looking like a little bit of a volcano or a tornado, right? It gets a little smaller as you go. They keep on getting a little smaller as you go. That's exactly what I'm looking for on these. Getting a little smaller, starting off big, working a little smaller. Let's see what else we have in the store for us today. All right, we just went over that. So here's what your assignment looks like today, just like that. So you have to find it for 12, 16, 18, and 28. Okay, I would start off with the prime factorization of 12. Break it apart. Of 18, break it apart. 16, break it apart. 28, break it apart. You also have to do this page today, okay? List the prime factorizations. So right now we're looking for the longest factor string. So we're going to take 27 and do the prime factorization of 27. We'll do this one together. How about 27? We have 3 times 9. 3 is a prime number. 9 is not. 3 times 3 times 3. That's all we have to do for that one. Let's keep on moving down a little bit. Take a look at these examples. In the past, kids have always kind of made some confusion here with what's happening. Watch closely. This means 2 to the 3rd power. This right here means 10 to the 4th power. So that means I'm going to go 10 times 10 times 10 times 10. Every year someone wants to put 4,000 for an answer. But look, kids, it's 10 times 10 times 10. So we just count the zeros. We have 4 zeros. And what? So it's 10,000. That's our answer. When you're doing these right here, it's going to be 3 times 3 times 5. And then tell me what 3 times 3 times 5 is. You don't need a calculator for these things. Right here, you're going to go 2 times 2 times 2 times 2 times 10 times 10. Kids want to do this in the past. They want to go 8 times 20. That is not correct, kids. You have to go 2 times 2 times 2, 2 times 2 times 2 times 2, which is obviously bigger than 8. Okay. Good luck with that. And down here at the bottom, it's very easy. You're just putting them into exponent forms. So if you have different kinds here, you're just going to go 5 to the second power, 3 to the second power. Got some more factor trees here. Actually, you don't have to do that page. You're going to have to do this page, though. Some more factor problems. Take a look at the examples. Examples will help you out. More prime factorization. I'm pretty excited about the lesson today because you're going to be working with your math facts, your skills, and you're going to be breaking apart larger numbers into smaller numbers. Good luck, kids.